Alright, so today we're going to look at quadratic equations, which we also did this in Algebra 1, but we're going to kind of take this one a step further, because now we have a concept of imaginary numbers. So take a second and try to work through 1 through 3 for me. Okay, so for what value of x is 2x minus 1 times x plus 3 equals 0 true? So if I said, what am I going to do? So I'm going to say 2x minus 1 equals 0, and x plus 3 is equal to 0. So x is going to be a 1/2, or x is going to be a -3. So if the factor is 0, the whole product is 0, right? So if the factor is 0, the whole product is 0. Oops. Okay, so this is called the zero product property. Okay. Alright, what about number 2? It says factor defined for what values of x is x squared minus 5x minus 36 equals 0 true. So I need to factor that. So what multiplies together to give me -36 and adds together to give me -5, which is what? -9 and a +4. So set both of those equal to 0, so that'll be 9 and -4. Alright, what about this one? So how can you find the values of x that make 3x squared equals 9x true using factoring? So we need to get it equal to 0 here. So this will be 3x squared minus a 9x equals to 0. Take out the greatest common factor, which is a 3x. I'll be left with an x minus a 3. Set both of those equal to a 0. Come over here and do that. So set both of those equal to a 0. So x will be a 0 and x will be a +3. Okay, so solving by factoring, what do? Set equation equal to equal to 0. We're going to factor. Set each factor equal to 0. And solve. We always like to check our solutions just to make sure they make sense. Alright, okay, so for number 4, I want you to try to do solve this one as many possible ways as you can. Okay. Alright, so I've got 3 ways here I could do this one. So we can multiply, simplify, and then factor. So if I multiply that out, remember that's x minus 5 times x minus 5. So this will be what? X squared minus a 10x plus a 25. So then that'll be x squared minus a 10x plus, minus an 11, not plus. Factor now, so we'll have x minus, what, 11 times x plus a 1. So x will be an 11 and x will be a -1. Will be my solutions. Okay. The other way that we did this was the square root property. So that means I have a square and I have a number. So I've got, oops. So I'll have x minus 5 squared minus a 36. If I move that over, so I'm going to move that 36 over, so I'll have x minus 5, all of that squared, is equal to a 36. Remember, then you take the square root of both sides. So you'll have an x minus 5, and when you take the square root, remember, you have the two possible solutions, so it's a positive and a negative 6. So we'll have x minus 5 equals 6, and x minus 5 is going to be equal to a negative 6. So x is going to be an 11, and x is going to be a negative 1. Alright, this is one you probably did not notice, but the difference of two squares here. So I could factor that. So this is a perfect square, so it would be x minus 5 minus a 6 times x minus 5 plus a 6. Then you would have x minus, what, an 11, and x plus a 1. Then you set both of those equal to 0. So x will be an 11, and x will be a negative 1. It's kind of neat, huh? Alright, so solving the standard form of a quadratic, okay, so produces our quadratic formula. Okay, so if I were to put a quadratic in standard form and I were to solve for x, if I completed the square here, I would end up with negative b plus or minus b squared minus 4 times ac all over a 2 times a. Where your a and your b and your c represent the coefficients there. Okay, so using the quadratic formula, it still needs to be equal to a 0, right? So this one, I would need to move over to the other side, so it'll be a plus a 7. So I want you to take a second and solve these three by using the quadratic formula. Alright, so my a is 1, my b is 7, and my c is a 7. So we'll have a negative 7 plus or minus 7 squared minus 4 times a times c, all over 2 times a. So negative 7 plus or minus, so it's a 49 minus a 28 all over a 2. So 49 minus a 28 is going to give me a what? 21. So I've got two real solutions. So the discriminant is what's underneath the radical here. So if b squared minus 4 ac is greater than 0, then we're going to have two real complex solutions. Okay, so it's something I can graph. Right? What about here? So my a is 1, my b is negative 6, and my c is a 9. So I'll have a negative times a negative, so it turns into a positive. A negative 6 squared minus 4 times a times c, all over 2 times 1. So I'll have 36 minus a 36, which is a 0. So my only solution is going to be a 3. So if what is underneath the radical is equal to 0, you're going to have one real complex solution. Okay, last one. So my A is a 2, my B is a -6, and my C is a 9. So I'll have negative times a negative, which is a positive, plus or minus -6 squared minus 4 times A times C, all over a 2 times A. So it'll be 6 plus or minus 36. 4 times 2 times 9 is a 72. And then over a 4. So we'll have 6 plus or minus, so 36 minus 72 is, 36 minus 72 is a -36. So what's the square root of a -36? Okay, so it's a 6i. Okay, so if I simplified that, that would be 3 plus or minus 3i all over a 2. So if b squared minus 4ac is less than 0, you're going to have 2 imaginary complex solutions. Oops. I'm not going to ever be able to graph these, right? But they are going to give me some imaginary numbers there. Okay. All right. So that is quadratic formula and by factoring, and now we've got the rule of our imaginary numbers and how that kind of plays in to solving. Okay. So if you have any questions, let me know.